Yeah. Yes. Yes. Okay. 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 Yeah. Hello, everyone. Good evening. Welcome to today's session. So, I am Akshay Acharya, and I'll be walking you through exciting project on SOP Chatbot. Okay. So, this project leverages the power of data science and AI to make business operation more efficient. Okay. Before we dive in, don't forget to like, share, and subscribe. Okay. In this session, we will cover the business problem and we aim to solve the objective and success criteria for the project, and an overview of the model architecture, the tool and technology we have used. Okay, let's begin by understanding the core business problem. Businesses often struggle with the operational inefficient due to the unclear and inaccessible standard operating procedures. This leads to a delay, error, and confusions. So then what is the solution for this? Obviously an SOP chatbot. Okay. The chatbot simplifies the access to information by making SOP available instantly to employees in a user-friendly manner. Okay. So next, what is our objective? So our objective is to maximize the efficiency and the consistency. Okay. So next, what is our constraint? Constraint is the minimize the cost and maximize the scalability. So what is the business criteria? So a reduction in the document processing by time at least by 30%. So whatever right now the time they were spending on the document processing, we have to reduce at least by 30%. So what is economics criteria? A reduction in operational cost by at least by 30%. So this is overall view of the business problem, objective, constraint, business criteria, and economics criteria. Okay. So let's see the model architecture. So here comes the model architecture. So in this model architecture, we have the multiple PDFs. So multiple PDF means it might be a 10 or a 20 or a 50. So based on their company requirement or their company standard operating procedure, they have given this PDF. So this is our input data. Okay. So our system starts with the collection of PDF documents containing the standard operating procedure. Okay, this PDF serves as a knowledge base. Okay, so next part is next once this PDF are feed into our chatbot or a model application, and then next step is the text extraction. So here we are going to extract the text from this PDF by using the different PDF reader, that is the PyPDF2 or a PDF plumber or unstructured PDF. Okay, so here in our model we have used the unstructured PDF. Okay, to extract the text from the PDF. So next part comes to the chunking. So what is the chunking? So what is exactly chunking? The chunking is the dividing the text from into the smaller meaningful chunks or a paragraph. So this is done. Okay, why you are performing chunking? So there must be some reason for chunking, right? So this is done. This is done to handle memory limitation and improve the accuracy of the search result. Okay, each chunk represents a meaningful, manageable unit and informative retrieval. Okay, this was the main objective of the chunking. Okay, and next comes the vectorization. So what is exactly vectorization do? So it will convert into binary part. So how we are going to convert? So using our embedding models. So embedding models such as we have Word, okay, and our OpenAI, and we have Google generative embeddings. By using all these embedding models, we have to vectorization. So once the vectorization done, then we are going to store it in our vector database. Okay, so we have several vector databases. That is, we have FIAS, ChromaDB, or a Finecone. Okay, in this project, we have used the FIAS vector database to store all the embeddings and vectorization. Okay, so this is the one part of the chatbot. Okay, this is entire one part of the chatbot from PDF. By giving the PDF as input to store the vector database is the one part of the our chatbot or application. Okay, next comes the user. Okay, here the user give the query based on the PDF. Okay, so whatever they have the question or the query on the related to PDF, they will going to give input over our application. So then the query, that is the whatever the question they were asking, that will pass us to our embedding model. So what is this embedding models do? This embedding models exactly converts that question to the vectorization. Okay, same thing happens here, right? The same thing happens in the query response also. So once it's done, by using the similarity search, okay, by using similarity search function, this query, okay, this query will search within the vector database. So what are all the similarity match? Okay, using similarity search, it will going to search what are the similar context present in the vector database. So we are going to retrieve the top 3 or 4 retrieve from our vector database. Once we retrieve the whatever the content present in the vector database, then we will pass us to our the large language model. So first we are going to user going to query the application, then that query or question passes to embedding model, then it will converts to vectorization. That vectorization is passes to similarity search function. Then whatever the question they were asked, that question related context. For example, I am asking what is today's production. If I ask the what is today production, it will going to check, okay, in the database. So what production is my key or a key factor. So it will going to check in the vector database of the production and today. So whatever related to content present in the vector database, it will retrieve and passes through over the large language model. Okay, large language model may be the, so we have a several large language model. That is, we have GPT and we have Gemini models, and nowadays we are we are hearing about the DeepSeek. Okay, the DeepSeek is one of the LLM, and we have Lava, Mixture. So these are all the LLMs. Okay, by using by help of these LLMs, we are going to give the proper response or a clean response to the user. Okay, so this is overall what you call it, the overall steps are the model architecture of the this chatbot. Okay, so starting from PDF, then it will pass us to a text extraction, chunking, and vectorization, then storing in the vector database. So second part comes here, the user and the user query or the question, and the embedding model and the vectorization, then the similarity search function. So once it's done, then it will retrieve the similar context or the relevant context from the vector database, then passes to the large language model. And here we have used the Gemini models for the retrieval context. So once we receive the retrieval context, then we are going to give the clean response to our user. So this is the overall model architecture of the SAP chatbot. Okay, so then next we are going to see the simple UI. So how it is going to look like. So here we are going to option to upload the file. Then here we are going to give the option to ask the question. Okay, so once we ask the question, based on the question, it will going to retrieve the whatever the content present in the our PDF or a CSV file. So this is the overall view of the our UI. So this is how our UI look like. Okay, so so this is all about our SOP chart. So when it comes to our 360, so what we offer, so challenging and real-time projects that pushes your limits too. Okay, so then learning for all phase of project methodology. Okay, learning about the different tools used in the industry like Python, Power BI, cloud, uh, cloud like AWS, GCP, and work on research paper that are published in the international journal. Access to various free tools enhance your learning. Okay, so when it comes to our free tools, we have mind map, and we have ML architecture assistant, and we have RO, that is resume optimization hub, and we have animated learning. So these are some of the free tool we offer from 360. You can find it in our 360 websites. Okay. So if you have any further inquiry, you can contact this number, and you can follow our social media platforms, LinkedIn, YouTube, and Instagram. Okay. Thank you friends for attending this session. Thank you for attending the session.